Okay, I'm supposed to show that both sides of this are equal, and I'm going to take this left side because fractions are more complex than non-fractions. I'm going to change this to look like this. So first thing I'm going to do is change the secant on the bottom to 1 over cosine x, and then I'm going to change the sine on the bottom to 1, I'm sorry, cosecant on the bottom to 1 over sine x, and I'm going to flip these upside down. So this is going to be cosine squared x plus sine squared x, which equals 1 from our Pythagorean identities. And this side over here, secant squared minus tangent squared equals 1. So I've shown that 1 equals 1. Over here again, I think that the left side is more complex because it's a fraction. So what I'm going to do is I'm going to change this side to look like this side. And since I know that secant and cosine both deal with cosine, I'm going to do a Pythagorean identity and plug in 1 minus cosine squared of y in for the sine squared. And just like when you add, let's say that's 2/5 plus 1/5, you're allowed to take both denominators both numerators over the common denominator. We can go backwards and split up these two numerators over a common denominator, because I'm going to split up this 1 and this minus cosine squared y all over the common denominator cosine y. 1 over cosine is secant y minus, and then this 1 cosine y will reduce with one of those, and that will leave me minus cosine y. And I just showed this left side gives you the right side. For number 13 was the next one you wanted. So 13, this left side's way more complex, so I'm going to FOIL this. So I'm going to take secant times cosine, and I'm going to take secant times negative sine, which is negative secant x sine x. I'm going to take cosecant times, I'm FOILing right now, so I'm going to take cosecant x times cosine x. And last, cosecant times negative sine is negative cosecant x sine x. So I FOIL those. This first one and this last one are multiplicative identities because they're inverses of each other. This one's 1 and this one over here is negative 1. And then in these two, I'm going to change these all to sine and cosine. So secant is 1 over cosine x, so I'm going to leave sine alone. And then here, this cosecant is 1 over sine x. I'm going to leave this cosine alone. So I hope you know 1 minus 1, these two cancel each other out. So these two together give me cosine x over sine x. And these two together give me a negative sine x over cosine x. So I hope we know cosine over sine is cotangent, and it's positive. We're going to move it to the left. This is a minus, and sine over cosine is a tangent. And if you look at this, this is exactly like what I'm supposed to show it equals. So you're done when you get them equal. And then you also wanted to see 15. So I'm going to come down here and do 15 now. Now to me, both of these are fairly complex. So I think I'm going to do both of these at the same time. Secant and cosine are multiplicative identity. They're inverses, so I get 1 from this. Tangent and cotangent are the multiplicative identities. They're inverses, so they get 1. And I get 0 equals 0, and I'm done with that one. I proved both sides were equal. Hope this helps.